Let's start by finding the slope of a line containing the 2 points, one with an ordered pair of 3, 7, and one with an ordered pair of 4, negative 9. So I now understand my slope is found by taking the difference in the y's over the difference in the x's if I need a formula, right? If I want to be real specific to that formula, I could do some labeling saying, all right, x coordinate over here, that's x sub 1. Y coordinate over here, that's y sub 1. X coordinate for this point, x sub 2. Y coordinate for this point, y sub 2. If I do that, to find the slope being the difference in the y's over the difference in the x's, I could take my y2 minus my y1, so negative 9 minus 7, divide by my x2 minus my x1. So that'd be 4 minus 3. Okay, subtracting all that out, you got negative 16 over 1, so my slope would be negative 16. Now, without the labeling, and say I just start with the first point, if I subtract my y's, if you think about this, it'd be 7 minus negative 9 if I go from first point to second point. And 7 minus negative 9 is going to be a positive 16, right? I would put that over, got to be consistent as I subtract here from point to point, so I'm still going from first to second with the x's. I'd put that over 3 minus 4. So that'd be 16 over 3 minus 4. 3 minus 4 is negative 1. 16 over negative 1, also negative 16. So just to show you, you don't always have to start with the second point. I could start with the first. It will work, but you do have to be consistent in how you go from point to point. So another example here, just basically applying our slope formula. Let's take a line here that passes through the point 3, 5 and through 3, negative 100. All right, if I'm going to find the slope of this line, say I start with the first point, subtract to the second point. So first point, y is 5. Second point, y is negative 100. I'm placing that over, being consistent from point to point here. Subtracting my x's from first to second, obviously it's not going to matter because they're both the same. Excuse me. So, as I subtract through the top, well, got the double negative, right? That's plus, so that's going to be 105. Subtract through the bottom, I'm going to get 0 back. What's true about this slope? Well, the slope's going to be undefined, right? There's no answer here. So this slope does not exist for number 2. The reason it does not exist is, one, yeah, we're dividing by 0, but the reason we're dividing by 0 is the x's are the same, and if the x's are the same, this is a special kind of line. You know what kind of line it is? It's a vertical line. So a vertical line has an undefined slope. All right, I want to do one other here before we move forward, just because I want to do one with fractions, and you know what that means. Fractions equal fun. So here's a line passing through an ordered pair of 1/2 and negative 1/2, as well as another point of 3/5 and 9. So we know how the game's played. We know how to set this up. Difference in the y's over difference in the x's. So this time let me go back to doing second point to first. If I do second point to first, take 9, the y value in the second, subtract y value in the first, which is negative 1/2. Divide that by, working second point to first, x's, be 3/5 minus 1/2. So with all this fraction fun here, probably need some common denominators, right? So common denominator on top here, well, common denominator is going to be 2. 9 let's see, that's 18 over 2. You're adding on 1/2 because of the double negative. That's all over. Let's see, common denominator down here is going to be 10, right? So I've got something over 10 minus something over 10. So to create this fraction here from 3/5, multiply by 2, it'd be 6 on top. To create this fraction here from 1/2, multiply by 5 to get to 10 there. Multiply by 5 on top, so that's going to be 5/10. Compute out a little further here. If I add these together on top, I'm going to have 19/2. On the bottom, as I subtract that, that's going to be 1/10. And then the rule is, as I divide these fractions, I take my numerator, I multiply by the reciprocal of my denominator, and I get 190 over 2, which we could do a little bit better than that, because it's 190 divided by 2. And 190 divided by 2 is simply 95. So the slope would be 95 for that line passing through those 2 points. If you're given a specific equation for a line, identify the slope. That's basically what we're doing here. Out of the 3 equation forms that we know, being slope-intercept, point slope, and then standard, now think about which one makes the most sense here to apply. I'm looking at y being equal to something. I'm thinking slope-intercept, right? That makes sense. Because if I go with the whole y equals mx plus b idea, I know I'm just looking at the coefficient on x. The coefficient on x will give me the slope. So m here, my slope, would equal coefficient on x, which is -1. The slope of that line is just -1. Pretty easy to identify if it's solved for y. So speaking of solve for y, what if I had y equals just 2? What would the slope of that line be? Well, I don't see an x. You see an x? You guys have younger eyes, you might see an x. No? Yeah, I don't see an x. So what's the slope? What kind of line is this? It's a horizontal line. So if it's a horizontal line, the slope of any horizontal line is going to be 0. It's kind of like you got a 0x plus 2. Then it'd be a little more obvious that your slope's 0. But just understand, for future reference, horizontal lines, slope is 0. So as long as we're talking about special lines, let's throw a vertical one in here. Let's do x equals -3. Kind of discussed this already when we actually had specific points to work with, but what's the slope of a vertical line? Slope of a vertical line is undefined. The slope does not exist. So part of recognizing which forms are probably best to associate with here is also recognizing if you have special situations for lines. Horizontal lines, slope 0. Vertical lines, slope does not exist. Another type of equation form we're used to seeing is a standard form. So let me give you an example here of standard form. Standard form like 5x minus 3y equals 9. We talked about on number 4 there how if it's solved for y, got slope-intercept form, pretty easy to identify the slope. We could solve for y here, but we did that a little earlier with our notes, right? We looked at ax plus by equals c, and we solved for y, and we found that if you use the relationship -a over b, that will give you your slope whenever you have standard form. So my slope here, knowing that a is 5 and b is -3, well, I'm going to take 5, put that over -3, and then understand that I'm negating this idea. So my slope is simply 5/3. Okay, let's play find the missing a. Gee, I don't know. If I think about what we've been doing so far, here's two ordered pairs. I'm talking about finding slope. I'm kind of in this mode right now where I just want to, subtract some y's and subtract some x's. Maybe I should do that here. So if I go from second point to first point, subtract my a and my 9 because that's the y's. Place that over. Well, again, second point to first point now. Do the same thing with the x's. It'd be 3 minus 4. That would equal my slope. Normally, I don't know what the slope is yet. I have to calculate further, but here I know what the slope is. So, guess what? I'm going to set that equal to 3/2. And now we got a pretty little equation here that we can solve for a. So I'm going to do a little cross multiplication. As I do my cross multiplication, I'm going to take this a minus 9, and understand it's an entire quantity here. I'm going to multiply it to this 2. So it's 2 times a minus 9. Important to distribute that 2 through here in the next step. And then 3 minus 4, we could just say, all right, that's -1. -1 times 3, get -3. So now solving for a, distribute 2, get 2a minus 18 equals -3. Add 18 over. So if I add 18 over, get 15, divide everything by 2, that missing a value is going to be 15/2. Find the a that makes the slope equal to m. There you go. Got your answer. Alright, so if I'm going to figure out what a is, on the last problem this seemed to make sense to do. Let's set up a little subtraction here of our y's and of our x's, and let's set that equal to our slope of -2. Now, as we do this, say that I go from first point to second this time. And say that I start with the actual numbers that I know. The actual numbers that I know are the x values. So I know 3 minus -1, well, that's going downstairs. As far as the y's are concerned, well, I know I'm starting with this first point here, and I'm starting with that a. I'm subtracting to this absolute value idea over here as my second part, but you know what? That's kind of throwing me off, so I'm gonna wait just a second. I'm gonna come back to this thought. In the meantime, I'm going to appreciate that all this equals -2. So now, what to do with the absolute value? Well, let's think about what the absolute value of a means. The absolute value of a means two things. It means that it could be a if that number a is positive or 0. It could also mean it's the opposite of a if that a is negative. So here's what I need to decide. I need to decide which one of these guys right here makes the most sense to input right there, because just subtracting the absolute value is not really going to get me anywhere. The absolute value is two things. I need one thing. So if I took a and I plugged in up here, would that make sense for what I'm trying to find? No, it wouldn't. Because notice what happens. A minus a, you get 0. If I get 0, that's not going to equal -2. So let's use -a. Let's subtract that guy. Let me get this other stuff out of the way here. Looks like I got something set up now that I could solve. If I clean this up a little bit here, right, double negative, add that, make that 2a. If I clean this up down here, double negative, add that, make that 4. That all equals -2. You can make that -2 over 1 if you want to, and try to do the cross multiplication like we did on the last problem. It really doesn't matter. A few ways we could do this. But if I cross multiply, 2a times 1, get 2a. 4 times -2, get -8. Divide by 2, a is going to be -4. So there's an a value that would work to get that slope back.